Welcome to aminacademy.com. In mathematics, regarding first order differential equation, let us do some applications. First order differential equation is defined by an equation dy by dx equal to f of x comma y. That is derivative of the function of f of x comma y of two variables x and y with its function of f of x comma y defined on a region in xy plane. It has only the first derivative dy by dx, so that the equation is of the first order and no higher order derivative exists. The differential equation in first order can also be written as y dash equal f of x comma y. Y dash means dy by dx equal f of x comma y. The differential equation is generally used to express a relation between the function and its derivative. For example, we'll discuss about population growth and decay problems. Now we consider the growth of population, for example, human and animal or bacteria colony as a function of time t. Let x of t be the size of the population at any time t, although x of t is integer valued because population is always integer value. We approximate f x of t as a differentiable function, and techniques of differential equation can be applied to determine x of t, that function of x with t. Assuming that the population grows at a rate directly proportional to the amount of population present at the time, then we obtain dx by dt. The derivative of x with respect to t is equal kx. Therefore, you can say dx by dt is kx, and where k is the constant of proportionality. Here the k is greater than 0, that is k should be a positive value since the population always increases. The solution of differential equation of x of t is equal to c into e power kt, where c is a constant of integration. The value of c and k are determined with the help of the initial conditions given. In problem, the initial condition should be given to solve the differential equation. Thus, the population increases exponentially with the time. This law of population growth is called Malthusian law. Let us do an example regarding this concept. The population of certain town is known to increase at a rate proportional to the number of people presently living in the city. If after 2 years the population has doubled and after 3 years the population is 45,000, estimate the number of people initially living in the country. Let us do this problem. Here, let n denotes number of people living in the country. N equal number of people. Living in town. That is at present living in town. Now, time t, country at any time t, therefore the equation dn by dt minus kn equal to 0 is a differential equation, and its solution of this equation, first order differential equation, is here n equal c e power kt, where c and k are constants. Then if at t equal to 0, t equal to 0, therefore n equal to c e power k into 0, which is equal n equal to c, because anything power 0 is 1, so n equal to c. N equal to c be here at t time equal to 0, that n0 equal to c. Therefore we have after at time t equal to, at time is doubled, t equal to 2. Therefore after 2 time is here, number of people present in the city after 2 years. Therefore time t equal to 2, the condition n equal to, and that is doubled, population is doubled. Now we substitute here, therefore to n0, to n equal to n0, which is equal n0 and 0 initial value, then e power 2k, because kt is t is 2. This is the equation. From this we'll find the k value. Look at here. Therefore k equal to half len 2. By using this, by taking l both side, k equal to half len 2, which is equal, half len 2 value is 0.347 by using calculator. Now this substituting this value n equal to n0, if n equal, therefore n equal n0 e power k is 0.347 into t. Now we apply the value, the population. Therefore the population is at t equal to 3 here, the population is 20,000, here not 45,000, let it be. Here the population is 20,000 equal n0, we need e power 0.347 into 3 years. So which is equal, therefore 20,000 equal n0, this value e power 0.347 into 3 is 2.832. 2.832. Then therefore n0 equal 20,000 over 2.832, which gives the approximately 7062. That means after 3 years, estimate the number of people initially living in the country. Initially living, that is n0, is 7062. Then population increased from these values. Now we got the initial population is 7062. Next question. A certain radioactive material is known to decay at a rate of rate proportional to the amount present. Initially, there is 50 milligram of the material present, and after 2 hours, it is observed that the material has lost 10% of its original mass. Find an expression of the mass of the material remaining at any time t. The mass of the material after after 4 hours. We have to find after 4 hours the mass of the material. Then at the time at which the material has decayed to one half of its initial mass. That means some radioactive material have its own half-life period. So it has reducing mass when time elapses. Means what? It radiate. Initially the mass is 50 milligram of the material present. After 2 hours, it is observed that the 10% of its original mass is decayed. Now let n be the amount of material present at time t. N amount of material at time t. Amount of material at time t. Therefore, we have the equation dn by dt minus kn equal 0 is a first order derivative differential equation. Now its solution of this equation, n equal c e power kt. Now the conditions given at time t equal to 0 at initial time, the given material n equal to 50, because initially it have 50 milligram, 50, and therefore from that equation we have 50 equal that is n equal to 50 e power n equal that is 50 e now n equal to 50. From that equation we have n equal to c e power kt, that is n equal to that is we have n 0, then n equal to n 0, that is 50 e power kt. K t is the time kt. From this, at n equal to 2, at n equal to 2, 10% is available, 10% is decayed. Therefore, available is, that is 10% of 50 is 5. Therefore, remaining is 45 gram. So, before 50 milligram is available, then 10% of 50, that is 5 milligram decayed. Therefore, 45 is balanced. Therefore, n equal to 45, which is equal at present originally 50 e power 2k, because after 2 hours, this is the equation. From this, we can get it k value k equal half ln 45 over 50, which gives minus 0.53. 0.053. That means by using calculator, we got half ln 45 by 50 is this. Now, substituting these values, that equation, that is n equal 50 e power minus k value is 0.053 and the time, this is the required equation for the amount at any time t, the first part. That is an expression for the mass of the material remaining at any time t. Then the mass of the material after 4 hours. After 4 hours, we have to substitute t equal to 4 here. Therefore, t equal to 4, that n equal 50 e power minus 0.053 into 4, which gives, that is 50 into e power minus 0.053 into 4, which gives 0.809, gives 40.5 milligram. That means after 4 hours, that material left without decay is 40.5 milligram. Then second part. Then third part, the time at which the material has decayed to 1/2 of its initial mass. Third part, look at here. Here, n equal to now half of the mass is decayed. That is n equal to 25. Because initially 50 gram, here milligram, it is 25. Therefore, substitute n equal to 25. We have 25 equal 50 e power minus 0.053 0.053 into t. We need t. Then 25 by 50 equal e power minus 0.053 t. So which gives, from this, therefore this is half, therefore we have minus 0.053 t equal to, taking length both side. Taking length both side is length of this length of e power, this one is this number. Therefore, we will take length both length is length of e power minus 0.53 t is 0.053 t only, because length of e power anything is that one, equal length of half, because 25 by 50 is half. From this time t, we can calculate length of half is negative values, therefore time is length half over minus 0.53. 0.053 gives, by using calculator, t equal approximately 13 hours. Which means That is, after 13 hours, the original mass become half of it. That is, it become 25 milligram in 13 hours. We have done. Please subscribe our YouTube channel.